Hey guys, so we're going to start to look at cubic graphs now. Now, cubic graphs can be a little bit confusing because they can look a few different ways. So today we're going to look at ones that are in this form, and then in the next lesson you'll see the other form. But let's just focus on this for now. Now, if you look at this rule here, hopefully you can see that it looks quite similar to the rule we use in quadratics, which was in turning point form, except instead of having that 3 there, it was a 2. So it was the same as this one we see here. So it showed us that there was a parabola and whatever the turning point is. Now this rule, it actually acts super similar, except the graph looks slightly different. So if you sketch this rule on your CAS, which is the most basic cubic graph, you'll see that it actually looks like this. And it has that special point here as well. So that's the same as turning point form, which your turning point would be at H and K. This time, that special point there, it's actually called a point of inflection, but it's still at H and K. Right, now what I want you guys to do is experiment a little bit before we go any further. Let's look at this section over here. So I want you to grab your CAS out. I want you to sketch that, as I said before. And I want you to leave that there. But at the same time, I want you to sketch one of these graphs as well on the same axis at a time. Okay, so leave that one there. I want you to sketch that one. And I want you to make a little note next to it saying exactly what actually happens. So if I compare this one to this one, what happened? So for example, I'm not going to show you on the CAS right now. You'll be able to see it if you sketch both. But if I sketch this one and then this one, I'll see that this one has actually become skinnier. So that should be telling us something about what this number in front actually does. So I want you to tell me what happens to each of these different ones. So I'm going to go over it right now, but I'm going to get you to pause the video and experiment yourself. And then once you've had a turn and you've kind of filled these answers in, play the video again and then you can see if you were right or wrong. I'd say you're going to be right because you can see it right in front of you on your CAS anyway. Alright, so this one here, this plus 1, that's going to move the graph up one whole unit. With this plus 3 here, we're going to see that this is going to move the graph to the left 3 units. With this one here, it's similar to that one up there, except instead of to the left, it's going to be to the right 2 units. And then the last one, we're going to see that it's actually reflected. Now you can reflect in the X or Y axis. Let's just leave it as reflective for the moment because with these sort of graphs it looks exactly the same. Alright, so after we've had a look at all these ones, we should be able to kind of know a little bit what these numbers actually do. So we can see these ones inside, they were moving it to the side. So this one moves us left, this one moved us right. This number at the end here, that moved us up. It could potentially move us down as well if it was negative. This number out the front here is controlling how fat or skinny our graph is. And if there's a negative out the front, that might reflect it as well. So if I move over here, here's a bit of a summary of what each of those different things do. So here's our general rule for this cubic graph. So A controls our dilation. There's some more details in there, so read over those ones. H controls horizontally, so we're moving left or right. That's that letter there. K controls vertically, so it moves us up and down. And same as turning point form, as I mentioned before, HK, the coordinate, is the coordinate of our point of inflection this time. Okay, so point of inflection, if we look at the black graph I drew up here, that point of inflection is that middle section there when it kind of changes direction. Alright, so let's go to our first example here. Now I've broken this example up into a heap of different questions just to kind of set it out in steps to make life a little bit easier for us, hopefully. Alright, so the first thing it wants us to do is give the coordinates of the point of inflection. Now remember, the point of inflection is at H and K. Now if we look at our general rule, there's h, and there's k. So let's apply that to our rule down here. So that means this one is going to be h, which is 2, and our k is 1. So we can say that the coordinates of our point of inflection is 2 and 1. So that's really important if we're trying to sketch any graphs, which we are right now. The next one. This is a yes or no question, but are there any reflections? I want you to ask yourself that every time because we want to know the shape that it goes. Okay, so if there aren't any reflections, the shape might look like that. But if there are reflections, it's going to look like that instead. So we want to know which one it is. So let's look at our rule here. Sorry, let's actually look up here instead. So if our A at the front is negative, it's going to be reflected. Or if our X is negative, it's going to be reflected as well. Let's look at our rule. I can't see a negative out the front. I can't see a negative in front of H, so there must be no reflections. No reflections. If there's no reflections, our graph will look like this one. Not like that one. That one's no good. Okay. All right. Now, the next thing we need to do is find out where the y-intercept is. Now, you guys already know with any graph, to find the y-intercept, you just make x equal 0. So we're going to do the exact same thing here. Make x equal 0. Sorry about that. Cool, so we made our x equals 0. Let's find out what this number is. So that's going to be minus 8 plus 1, so minus 7, which is our y-intercept. So if we put it as coordinates, which we should show it as in the graph, that's the coordinate of our y-intercept. All right, let's move on to the next part, D, which is locate the x-intercept. Okay, so that's pretty similar to y, isn't it? You just make y equals 0. There we go. I should have actually left more room here. Okay, so we want to make x a subject. So let's move this one over there. That's not a 2, that's a 3. Okay, so we want to get x as our subject, but we've got this cubed out there. Remember, if that was a squared, we could square root it. So if it's a cubed, we're going to have to cube root it. So we would, might just do it in a different color so you can see. We'd have to cube root this side to eliminate that, which would mean we have to cube root this side as well. So that's going to end up giving us, I'm going to have to start up here just because there's not enough room. So the cube root of negative 1 equals x minus 2. Now let's just sort this bit out first, because you guys know how to do square root, but cube root might be a little bit harder. So what it's actually asking is what number times by itself 3 times gives us negative 1. Negative 1 times negative 1 times negative 1 is negative 1. So that's our answer to that one. And now it's going to look, will be a lot easier for us to solve for x. So x is going to be 1. There we go. So we can put the coordinate down because we have to show that in our graph. We've actually come up, we've found all the key points that we need. So we've got our point of inflection, we've got our y-intercept, and we've got our x-intercept. So all we need to do, connect all those points, put it in the proper shape, and we have our graph. So I'm going to quickly set my axis up, put those points in, and we'll finish it off. Make sure you're labeling your axis. Alright, so our point of inflection was going to be at 2 and 1. So 2 and 1, let's just say it's around about here. Doesn't have to be perfectly to scale. Awesome. We want our y-intercept, which is at -7. Let's just say it's around about down here. Okay. And the last thing that we need is our x-intercept, which was at 1. So if that's x is 2, x is 1 is going to have to be here. Oops. That's supposed to be a 1 there. There we go. Alright, so we need to make sure we show our shape here. Now that's the point of inflections, and we have that shape. So it's going to come down something like that, have our point of inflection there, and then run down like that. And we're done. We've shown all key points. Point of inflection, x-intercept, y-intercept, and we've labelled our axis. So this graph here is all good. We should get full marks for that one. Let's do another example. And this will be our last one. So in this exercise, it doesn't only talk about those sort of graphs we just did then with the point of inflection. It actually talks about ones that look like that as well. So we've got a power of 1/3, which is cube root as well. So I just want to remind us back to inverses, which we did in 5G, because that's pretty much what we're using right now. So this is the sort of graph that we were looking at. But what I want you guys to do is try to find the inverse of it, because we're going to see that the inverse of the graphs that we were just doing are ones that have that form. Okay, so hopefully you can see that once we start or finish off this example. So, all right, firstly, we want to find the inverse of this rule here. Okay, so to find the inverse, I need to follow these two steps. I'm going to swap my x and y. And then I need to solve for y, or make y the subject. Okay, so I need to get this to the power of 3 out. We did this before, so you're going to end up having cube root of x equals y. Now, cube root of x can be written in another way, which is x to the power of 1/3 equals y. So that's our rule. But remember, we did try to find the inverse, and it's important to use the proper notation. So we would say f minus 1, that means our inverse, equals x to the power of 1/3. Okay, now let's think about what this graph, if we're going to graph it, might look like. So we initially had x to the power of 3, and we saw before that that graph might look something like this. But we just found the inverse of that. Now the inverse graph is going to be reflected in the line y equals x, which is this line here. Hopefully you remember that. So that means that everything that was on this side of the line is going to move to that side. Everything that was on that side is going to move to that side. So the inverse is going to look something like this. So that black one there, that's the shape of these graphs that have 1/3 as their power. Okay, so that's sort of what we're going to be looking at, or the shape that we're going to be seeing when we do graphs like this. Okay, now we need all the same kind of points. This one here, the black one, it pretty much has another point of inflection in that same spot. So our H and K rule, it's going to work for this. So if I want my point of inflection, it's still going to be H and K. So that means we've got 3 and 1. Another thing that I need to check for is whether it's been reflected. I can't see a negative out the front. I can't see a negative out the front of x either, so it hasn't been reflected. So we're going to have that shape. So it should look something like that. The other things that I need are the axis intercept. So let's find our y-intercept by making x equals 0. Oops, I want y-intercept first. Okay, so now with this one, that means we've got 2 times the cube root of -3. Right, now the cube root of -3, I'm not going to be able to get a full number out of that, so we're going to leave that as it is. So this is going to be our y-intercept. That's done, finished. Okay, so if we put that as an coordinate, we'd have x is 0 and y is 2 times the cube root of 3 plus 1. So that's what we're going to show on the graph. We also need our x-intercept as well. That's going to be the last thing that we find out. And we make y equals 0. Okay, now we want to make x a subject. So let's move. Let's move this 1 over there and the 2 as well. So we're going to get -1/2 on the other side. And we're going to be left with this over here. Okay, so we now want to get rid of this here. So that's the same as cube root of that. So we want to cancel this one out. So to cancel out a square root, you square it. To cancel out a cube root, you times it to the power of 3. So what would be happening is we've got this whole side to the power of 3. It's going to cancel that out, which means we have to put this whole thing here to the power of 3 as well. Okay, so that's going to give us -1 up the top, -1 times -1 times -1, and that's going to give us 2 times 2 times 2 down the bottom, so that's 8. So -1/8 on that side is x minus 3. Alright, we want to solve for x. So it's going to be 3 minus 1/8. Okay, so let's put these together. Okay, so if we're going to have the denominator being an 8 over here, that's going to be 24 on 8. So 24 on 8 minus 1 on 8 is 23 on 8. And that is our x. Oops. That is our x-intercept. Sorry, I didn't realize that was off the screen. So now all we need to do is sketch it. Let's put all of our key points in. So point of inflection was 3 and 1. 3 and 1, that can be around about there. We need our y-intercept. Let's think about what this number is going to be. It's going to have to be negative. It's going to have to be more than 1. So let's just say it's -1.5. 2 times -1.5 is -3 plus 1 is -2. So that's going to be a negative number. So it's going to be down here. Somewhere down here. I don't know exactly where. there we go, there's our y-intercept, and we need our x as well, which is 23 on 8, which is just under 3, so it's going to be around here. There we go, we've got all our key points. Now we need to put the correct shape in. So now remember, the shape is that black one there. So it should be something like this. Something like that. Now it's a little bit messy, but that's okay. We just need to know that that one there is the point of inflection. Maybe something like that, and get rid of that bit there. Now this graph that I've just done, as in this whole thing, and the graphs like this, they're not necessarily as important, or you won't see them as commonly as the ones from earlier. So you're going to see these ones, that kind of thing, way more, but still make sure you spend a little bit of time working on the other ones, because you might see them, it's just these ones, sorry, are going to be more common. Thank you guys, have a go at the questions, and make sure you're asking any questions that you have on the questions section in our team. Thanks guys, see ya.